webcast, which is part of Autodesk's continuing series on connected fabrication. This is Mary McDonald, Director of Marketing for CADsoft Consulting. CADsoft Consulting is pleased to be part of this series. We have been an Autodesk partner for over 25 years, and we are focused on the building, construction, and mining industries. And Chris, could you push it to one more slide? Today we have a great speaker lineup for you, including Chris Perry, Building and Construction Solutions Engineer for CADsoft Consulting, and Brandon Vaughn, Level 3 Mechanical Designer for M3 Engineering and Technology Corporation. Chris has worked for over 29 years in the architectural, civil engineering, structural, mechanical, and visualization markets as a design engineer and project manager. He holds many product specializations, including Advanced Steel, and has worked with Autodesk products since 1988 and has been with CADsoft since 2004. Brandon has spent his whole life in construction or construction-related industry. His dad started putting him under a welding hood at the ripe old age of 7. He has always been a natural designer, so decided to get a degree in design. He loves what he does and loves learning new technology. Brandon has worked with AutoCAD, Inventor, Revit, 3ds Max, and now Advance Steel. Next slide. Thank you. So CADsoft Consulting, as I mentioned, has been in business for 25 years, and our team of account managers and certified technical experts specialize in technology that accelerates the AEC industry's progress. But also I want to tell you a little bit about M3. They have been providing continuous design and construction services from project conception to final testing and integration across all 3 of the AEC disciplines. They have proven expertise developing creative design solutions for a wide variety of project types, ranging from complicated dynamic structures to state-of-the-art research laboratories, and are well-known industry leaders in mining. M3 is a longtime customer of Autodesk and CADsoft Consulting. So before we get started with the actual presentation, some housekeeping. If you have any technical issues, please make sure to type them in your chat feature, and we'll monitor them and respond as needed. And also, we also encourage you to type in your questions in the Q&A box, and we'll answer as many as possible at the end of this webcast. So now I'm going to turn it over to Chris to kick things off. Chris, you now have the floor.
Thank you, Mary. Good afternoon to everyone. I'm glad you could join us today. As Mary said, just to reiterate, we are recording the session, so if you want to review the session at a later date or share that with other team members, you certainly will be welcome to do so. A link will be provided, and I'm sure we'll have it posted on Autodesk websites as well as our CADsoft website, where you can access there also. Welcome to Brandon today. I've had a good time talking with him about his success with utilization of Advanced Steel. We're going to have some projects to display of his, as well as a little bit more for the industry that M3 serves, which is just about every industry, it seems. So we'll see a few images of projects that they are involved in. But today we're going to be talking about Advanced Steel and how it may serve a role in the mining industry. Now, largely, what we deal with, clientele-wise, we see that the people in the mining industry like to use Plant 3D. Plant 3D, however, is a process piping application. It does have steel features on board and a few other things that do suit the necessary approach to our structural steel teams. However, there's some things on the mining side for materials handling, we'll say, that it just may not have things on board. Now, if we have certain of the items that we'll look at here, certainly Advanced Steel, in its name, it has steel framework, steel connectivity, a lot of things for building structures, framework, support. When we get into vessels and other items, whether we have crackers or we have ball mills, anything materials handling wise, and anything to house those approaches, such as you see here. This is one of M3's projects. We see large structures that house, like that last ball mill photo. We have a lot of enclosures that we need to clad, And cladding is an aspect that we can find in Advanced Steel, and there's a lot of benefit there that we can even generate shop drawings on. But from the Plant 3D side, we usually find that in order to do this, we're using some CAD approach. Incline conveyors, overland conveyors. We don't really see tools in any of our applications that are well suited for this. So we are often found on the mining side that we work in several pieces of software to generate the general assembly, the engineering drawings, erection drawings, and shop drawings as needed. And don't forget, of course, we need pathways and other alignments that may be drainage. It may be passageway for any vehicular access and so on. So Civil 3D, being an engineering package, can suit that purpose, and we find that a lot of our mining clientele utilize that package as well. So how might we do that? I mentioned AutoCAD. Even at its base approach, certainly to do P&IDs. Another reason that we like the Plant 3D software, that we can do P&IDs. There's a lot of smarts built into the P&ID module that works inside of Plant 3D, but we could do that in just regular vanilla AutoCAD. I mentioned Civil 3D for the civil engineering aspects on a mining site. AutoCAD Plant 3D itself with P&ID on board. Navisworks Manage. I hope no one forgets the aspect that when we generate these big three-dimensional models in whatever software it may be, Navisworks Manage is a capable tool that can support multiple model file formats from varying industries and varying suppliers. One that you might think a little unusual, Revit. Its structural aspect, we don't really refer to them as architecture, structure, and MEP so much as we used to. We now have Revit all-in-one. All the disciplines are inside the application that we now title Revit. But I find several clients utilize Revit for the structural aspect. They like the ease of modeling with the building information modeling approach, being able to handle that steel. I'll have some images for you in terms of then the problem becomes, how do we collaborate or coordinate between differing applications? We don't necessarily have a Revit plant or a Revit civil. We need to move pieces of information from one application to another. Another aspect that we find involvement of the things that Mary mentioned to you initially that CADSoft does as services, we have been hired by some of our mining clientele to actually go on site, whether we are doing drone service flying, a UAV approach to do aerial capture of imagery and converting into topography that we can use in Civil 3D to generate alignments, earthwork calculations, and so on, or terrestrial-based scanning. We have performed these kind of things, so we find then that Recap Pro actually is a processing software in our Autodesk suites that we can utilize to deal with the point clouds that we can bring into all of these applications. Now, these are only a few, and I'm sure everyone has probably heard of or you already have used the building design suites. Of course, that's a little bit of a name of old, and now with this year's release, we see that we have collections, and I'm showing you these package names here because inside of the AEC collection, which the real advantage now is that Plant 3D has moved into the building, the AEC collection. We also have Civil 3D, we have the Recap, we have Revit, Navisworks. There are 20 applications and cloud services that exist inside that AEC collection, so that better flushes out what we may find ourselves using in how we have to kind of span the differing applications to do the differing discipline roles that we utilize inside the mining industry. So today's focus is Advanced Steel, and just in the very most simplistic summary I can give you, 3D modeling for steel detailing. Steel detailers may just simply be doing the design of connections. There may be a little bit more on design, but not only can we generate a digital prototype that we can also generate shop drawings, but we can further push that into fabrication and then construction. There's a lot of capability inside that application. So what does it do? Here we're seeing an image of that digital prototype. We come into Advanced Steel, and by the way, let's mention that Advanced Steel sits on top of plain vanilla AutoCAD. A lot of the commands and familiarity we have if we are AutoCAD users. Just all the simple copy, move, rotate commands exist inside the application. But we're coming in here and we're now generating a 3D prototype. And I get a little capture of the fact that we have specialized tools, and we'll find that Advance Steel is macro driven in that making these connections and placing these parts and pieces are automated in a certain nature to get all of the instances inside of a large project get us to that point so that we could then more quickly generate the documentation. We have a manager on board inside Advance Steel that gives us the ability to organize our single part drawings, our main part and assembly drawings, our GA drawings, erection drawings, and so on. And also the ability to have reports and lists of many different kinds of things. Some of the drawing appearances, we see that we have strategies that are right out of the box for labeling and annotation, for dimensioning. We can customize those to our need and our liking. We see that we can generate automated plan views that include parts lists like we see here on the right side of that page. The marks are indicating that the program works by a process of making piece marks and then assembly assignments for everything within the database of the model, and we can pull those out in those types of structured lists. Looking at assembly drawings by just the push of a button, and that may make it sound a little too easy, but we do have those out-of-the-box styles for creating assemblies on selected pieces or the entire model if we choose. We see beams, we see the layout of any penetrations of holes, studs if we have those on beam flanges, we see cross-sectional cuts, and all of these things are happening automatically driven from the drawing styles or drawing processes that come from the application. And then I mentioned about pushing toward fabrication. So we take the model, we generate the assembly drawing. The assembly drawing has a lot of database connectivity to it. We can then create numeric control output. We create DXFs to push these out to presses and punches for plate creation, beam lines, and so on. So we have the ability to generate fabrication right from the model that we have coordinated. It is a fabrication level of detail model and everything we need. So a real plus that it can offer. Now, specific to the mining industry, we may be wanting to do some specific things. Why might we want to use this in conjunction with what we do in plant? Plant does have the ability to generate some rudimentary profile sections. It has a large database, whether they be tube steel, standard pipes, wide flange sections, angles, channels, miscellaneous channels, and so on. It even has railings, has stairs and ladders. Advanced Steel has the same capability, but yet we have the a benefit, and the strength that really comes from Advanced Steel is miscellaneous steel. So here we're looking at an image of a conical folded plate, and we see the facets at the radius corners. We have a rectangular or square to round shape transition with beam flange mounts that are bolted, if you can see the bolt shapes there. But the benefit there is that Advanced Steel can do something that the plant work will not do, and that is simply unfold this. And in our drawing generation, we can take that unfolding, and it will, however we define, place automated dimensions on there. We can break that up into multiple pieces if in case it is too large for shipment or too large for handling, and we can, it gives us the ability to manage that. I mentioned the benefit that it runs on top of AutoCAD, all the familiarity there. The fact that it has a level of detail 350 tool for stairs and railings in this simple little capture here. Full editability of all the parameters and how we want to define these. And one of the other great benefits is how we can go in and save configurations. Like if this particular stair and railing configuration was one I want to use again and again, which is an expected approach, I don't want to have to set those parameters up each time. I can save it to the library and with a single click apply that in a future project or in this same project on another instance. And I mentioned, of course, the connectivity. That's the real crux of Advanced Steel, is that I have these macros, and you see by name, I can create clip angles end plates, moment connections, shear plates, through plates if I have tube steel sections, and so on. Having this information that can actually place these parts and pieces and then give me editability at the time I'm creating them or to come back after the fact is a real advantage in terms of steel detailing. All right, well, why might we use this? And if we do, how might we do so? Well, I mentioned some of the other applications, and I'm going to talk about really three here: Plant, Revit, and Advanced Steel, of course. So in versions of old, if you've ever tried to utilize with a steel package, we always did a steel detailing neutral format, that SDNF file format export. Okay, that's something that existed inside of Plant. It still does, even though if you look at the most current version, we find that now there is a button that simply says Advanced Steel Export, and that is a steel markup language, SMLX, a little bit different file format, so people might wonder if they've used the SDNF file format export before, did it go away? No, you could actually type it in on the command line. It still exists. You would see it autofill with AutoCAD's feature, so that if you still are wanting to use that, that feature is there. But in some form, we need to get this out. All right, on the side of the fact that I mentioned some users like the building information modeling approach that Revit can provide for structure, it can utilize, you see highlighted in my screenshot, Advanced Steel plugin, in that we can do the advanced import or export. Revit can actually perform a synchronization back and forth. We find this on the building side a little bit more. We'll take the Revit design model, we'll do an export, send that to Advanced Steel. The steel detailer can do the connection design, send that back in a synchronization. You can actually display the connected fabrication model inside of Revit. So you have the ability for the advanced import export. I'll mention that Plant 3D does not have that capability. We don't want to send that back and forth. We want to actually move the drawing, which I'll show you an image later, into the plant project because it has its own folder structure. But the Advanced Steel also gives us access to a couple of other file formats. That SDNF that I could take out of Plant and other applications can also be loaded into, as well as generated from Revit. So we have a couple of options. You even see at the bottom of the list there the CIS2, the SimSteel format. Somebody probably can remember what SimSteel stands for. We get so used to acronyms. I think it's more along the lines of computer integrated management for steel fabrication and construction, something like that. Might be pretty close. All right, once we have it either sent out of Plant, sent out of Revit, we're going to go to Advanced Steel. And here's a shot from the Import Export tab on the ribbon in Advanced Steel. You can see that there primarily we want to think about that steel markup language. We can import, we can export, and send those to Revit, or we can receive that from Plant 3D. You also notice to the left of that IFC functionality, CIS2, SDNF. There are a couple of others in there that we could probably exchange. There's even a dedicated Revit import export, and I mentioned synchronization panel on that particular tab of the ribbon. So we have some varied approaches that we can utilize. So once we take that into Advanced Steel, we do our connection work. We are working in AutoCAD, so it's a DWG file. But any of us know that when we've tried to bring in other detailed drawings, or in this particular case, we're talking about a 3D steel model, I have to copy the project into the project manager of a Plant 3D. So we add that to the project, and here in the folder structure, I'm showing the sample project that actually comes with Plant 3D right out of the box. We have to do so that it falls inside the proper folder structure, and there the steel detailer, if we're in-house, we actually work from that Plant 3D models folder where we store the steel model for fabrication and all of its associated folders, because it is also a project approach. Now, once it's into Plant 3D, we can take some advantages of that. If you've ever customized your user interface, if you're a liker of rollover tips, part of the CUI is what we can control the display of within our interface. The Advanced Steel items inside that drawing we copy over to the Plant 3D project. We can bring in particular properties we want to see in a rollover tip. So here I've selected categories of items. Once I have those categories, I can select them in my CUI interface, and then to the rightmost pane, I can say, hey, I want to see these things in my rollover tip. I want to know what the weight is as I'm looking at things. I want to look at material, model roll. I want to see what that section size is. And once we have that CUI customization performed, then when we're inside Plant 3D, we can hover over this and we can see the parameters that are part of that file. So we see the profile sections, the W12 by 40. We see the length. We see the actual weight as well as the weight generated by the system length. It may have a cut length to it. And what is the material? So some real advantage of information that we move between the applications. Okay. Well, at this point, and hopefully I've moved along quickly enough that I can give Brandon enough time to show his excitement and what he has enjoyed about the efforts he has made. So I'm going to show you in a minute here inside Navisworks, as well as we'll bring up some things inside of Advanced Steel of 2 sample projects that Brandon's been so kind and M3 has allowed us to demonstrate. And I'd like to ask a few questions of Brandon that will help give us a little bit more information. And some of these images I'm going to show you right now on Brandon's screen are his office and a couple of their projects. So thank you, Brandon, for joining us today. I'd like you to maybe give us a little bit of a feel. You've stated to me that your role with M3 is a mechanical engineer. You're not really sitting on the steel team, correct?
Right. I do mechanical design is what I do for those guys. And I work a lot with the structural, but I'm not really on the structural team.
Yeah, and Mary mentioned that you've used several pieces of software, and as diverse as M3's projects are, and many departments, having visited your company, I can just imagine you guys probably have about every piece of software that Autodesk has and know how to use it. So my interest is what kind of pushed you toward Advanced Steel? Why did you think that would work for you?
Well, it seems more and more shops are really wanting the shop drawings done and stuff, and we attempted that and other programs. I know we did it in Inventor, and Inventor's an incredible program, and it's great for what it does, but with Advanced Steel, you can just pipe out so many drawings so quickly. Literally, in just minutes, you can do 100 drawings. I mean, it's just really, really quick. And so we were really, the focus and the reason for using Advanced Steel was that strength in it, and it's easy to detail in there. It's easy to do the drawings in it.
Okay. Well, I'd like them to not take it from me, but what was your thought on the ease of use and learning, kind of, I guess, related to AutoCAD and the fact that, how did you go to approach it? Brandon didn't come to me for training, which is fine. That's fair. I imagine with his ability, he probably taught himself a good deal, but can you share with the listeners what you thought about how easy it was to get into it, if you think so, and what was your approach to beginning the learning process to Advanced Steel?
Well, I thought it was incredibly easy to learn and use. I'd never seen it before. The very first thing I did in this program was this real large set of chutes, multi-layer chutes. I actually designed steel and everything in that area, and it was a retrofit to an existing steel structure that was there. So in that whole system, there was like diverter gates. There was, a lot of complicated stuff, and that was the very first model I ever did in this program. And I actually did it with a 30-day trial. That's before we got any license or anything. And so it was super easy, very comparable to Revit in a lot of ways as far as how you can mold and manipulate things, but it has some strengths that I really loved. It's a little beyond Revit, was how you could just simply cut plates and just reshape them and stuff, and stretch them. You could do that just like you do in Revit, stretch them over, extend them. I mean, it's very, very easy to model in. For me, it was.
That's good to hear. I agree with you. I'm whole hog Revit. I do a lot of stuff in Revit. I do structural work, so it was natural for me to come into Advanced Steel. And many of us, if not practically all of us, have used AutoCAD at some point. And it was an easy translation. I like the macro-driven approach and the parametrics, what you're mentioning, the editability of those plates. And you know, I'm in Navisworks at the moment, showing one of the two models that Brandon provided to us. And might have him describe a little bit about this. He's got it titled as a feeder, right? And this is loaded with plate work.
Right. It's a feeder. It's coming out of the filters. If you zoom in, there's an interesting part of this model right here. If you zoom in on the skirt board, there are those connections you're looking at down there on your skirt board. Go down, down, down.
Okay.
That little knee part of that's all done with Advanced Steel. I didn't do the beam and all that connection, that whole entire little connection there is Advanced Steel, that coming off of that skirt board and going over to the beam there. That piece between the skirt board and the beam, that's a Advanced Steel piece. So you can actually do stuff like that with ease in this program. And changing things in it, I found was very easy. Again, it's a lot like Revit, but it's got a little more control in that you can select something and tell it which direction you want it to move and how far, and you can turn off your other UCS directions and stuff and move it only in one direction. So things like that, extending beams. If you select a beam and it'll give you a grip on the end of it. If you hover over that grip, it'll give you your UCS, and whatever direction you want that beam to go, you grab that UCS, and no matter where you snap it on the plane, it only goes in that direction. So it makes it really easy to extend beams and do things like that. Everything in the model except that bearing right there is probably, I think, is done in Advanced Steel.
Okay. I wanted to ask you about that. It's interesting. As with anything, not any one application does or has everything that we need. You know, we're looking at some unique items here. We've got these trough idler arms and other tensioners, and you mentioned this bearing or its mount. These items, if I remember our discussion, are they inventor items?
No. This is.
Okay, you did do these. Okay. What about this item here?
All of that is built in advance except the bearing. And what I did is I built that in another, and I brought it in as a special part. And that's what enables you to bolt to it and stuff. If you use the tools in Advanced Steel, like the special part tools and stuff, it recognizes that piece, and so it gives you the correct bolt lengths and stuff when you bolt it. If you zoom in on the idlers, you'll see the bolts on the idlers. It's the same way. I built the idler in Advance, but I brought it in as a special part. So when I bolted it, it recognized it, and it bolts all the way through the part, and it gives you the right length for your bolts and stuff.
That's right. Yeah, and that's one of the things I was really wanting you to mention to them, is that when we have parts and pieces, especially with materials handling like this, we can build them in plain AutoCAD if we like, just simple 3D modeling. It could come from Revit. I could bring vessels or other items that need some connectivity, mounts, whatever it may be, even out of plant, the plant equipment and other items that may be there. If I want to detail that up, or I want to generate some connectivity, I can X-reference the plant information into Advanced Steel. Whatever approach I may take, the interactivity is very effective. And the fact that we make it that, what you called it, an Advanced Steel special part, it's like a special block that sits inside Advanced Steel, and then the connection macros will work with it. One of the advantages that we can gain is that inside these objects, you might need to put an AutoCAD point. You might need a line reference or something, so that way you can snap to nodes and things that are a lot more dependable in the placement of those items. So, yeah, I definitely wanted you to tell them that.
Yeah, if you bring it in as a special part, though, it knows it. It's different than if you bring it in just as a block. If you use that special part tool, it definitely recognizes it a little differently.
And also, very interesting that I believe you made this out of parts and plates, and made a folded plate out of it, so we can even see a transition. And he's just representing the conveyor belt here, right?
Right.
So you could even give it a material and a coloration, and that way we could populate that inside of any GA drawing. We see the context of what we're after, and that's usually some of the things we're challenged with. Let me quickly open that other file. You can tell us about it a little bit, this type of chute object. Tell us a little bit about this one.
All right, this is coming out of a mill, out of a ball mill, and it's got a diverter. If you look in this steel, it looks like a steering wheel. That's kind of a little diverter gate to where they can kind of control how much flow they want from one sump to another. And so all of this whole thing is advanced steel. And some of these liners are rubber. That's one of the beauties of advanced steel. It's just that it's endless. The materials and the different types of steel and stuff are just endless. I found the steel library in this thing's just crazy extensive. It is. I mean, it goes on and on and on.
Yeah, we might mention that the countrification in terms of sections and materials and other things, you can utilize many sections if you find that your company, like M3, working internationally. We're not stuck to just imperial, or not just stuck to metric, but in terms of the profile sections, fasteners and other items, there's a countrification there with a very large database of things that we can add custom items to. You know, if we don't have something that we need, or if there's something very unique about our particular project, a mechanical assembly, we can create our own custom user sections, our own custom connections, and so on. So it's very, very helpful. All right. Yeah, this one was interesting. There are a load of plates on this. We've got externals, I guess you'd say there's stiffeners on these plates that house the enclosure. Stiffeners here, lots of bolt work. I don't remember if I did a bolt count on this one. It was in the hundreds. The feeder model we had up last, I believe when I looked at plate parts, there were over 900. That's a lot of stuff to model. So having a tool that can help generate that in a little more automated fashion can be very advantageous if we need to go the modeling route.
Yeah,
let me, oh, go ahead, Brandon, I'm sorry.
I was going to say, it'll produce those drawings incredibly quickly too, and the single part drawings are just usually really decent shape. I was really surprised at how well it did those. And some I noticed in the assembly drawings there's a little cleanup, but it's really amazing how well it does the drawings.
Yeah, we'll open up some drawings here in a minute and look at that. Brandon gave me an earlier version. Of course, I don't want his proprietary information, so I generated some stuff out of the box, and we'll open and look at that. But we're in Advanced Steel at the moment, and we are looking at his actual project. And you'll see that, you know, if I double-click on any of these particular items, those macro dialogues that pop up here, and we see that, okay, it has a width and a length. I can define an absolute thickness to that. I can edit it after the fact, change materials, positioning. When we get into documentation, you can see that in the process of numbering and prefixing all the parts and pieces of a model that we develop, you can see that that's part of the object's parameters. And I can even define them in specific roles, whether they're braces or plates or a specific type of plate, and so on. You know, this is what the drawing styles look to actually generate those automated drawings. Now, let's see. Let's look at the document manager here. I said I had created a few, so let's take a quick look at some. We want to save enough time if people have any questions that they'd like to ask of us. We want to try to get those answered and have some time to do so. So inside of our document manager, you saw a screenshot of it a little bit earlier. I have generated some part drawings. You can see the name, and we have complete reign on how we want to generate our numbering conventions, our drawing names and numbering conventions. I don't have any GA in here, so I'll show you how we can quickly generate a GA drawing out of a particular viewpoint. Let's just click on a few of these. We have property information. We can preview the drawing, the part drawing. This is just simply one plate, but note in its labeling that, wow, okay, I've got 138 of these pieces. The application knows that if something is different, it makes a new part designation. Here we have this plate and size and material, this layout, and we see the structured list down here defining some information about that and the count. We can even generate reports and structured lists that can exist on drawings that show weight, such as we see the total weight of all of this particular part. A lot of useful information right there. Some drawings may fit, some may not. They usually require a little bit of tweaking, but we can see even in its simplest form, these are all part drawings. I generated these on B-size sheets. I find that our shops really like having a smaller format, an 11 by 17 format that fits on a clipboard. Having the number of part the same as the drawing just, eliminates manual error or confusion at times. And since these are single part drawings, very likely they all fit very well. Advanced Steel finds its limits, how we define the prototype. It will set a scale automatically for us. And just, like I said, we have the ability to kind of customize a lot of things we want. Now, I said that I didn't have any GA drawings. Let's just look at how does Advanced Steel do that. And Brandon has mentioned more than once about how quickly it can generate data. That list of part drawings there took about 3 minutes, I think, when I generated for that, but I still didn't want to take up time for us today in doing so. But let's look at some of the drawing styles we have. We have a collection of engineering drawings, GA drawings by title, and you'll note that very helpful tips that it gives us when we hover over a particular type of stylization we want to use. It's a 3D model with labels. So it even gives us information about how to do it. Again, that easy aspect of using the tool. We want to generate a 3D GA drawing here. I'll just say, click on this particular option. Now, the thing about it, and I didn't remember to do so let me cancel that. Note what it says. 3D view at a UCS. So I have to set a UCS. So that gives us a chance to look at our Advanced Steel tools. So if this is the view I like, I'm going to come in here and I'm going to actually define the view. So I have a tool that allows me to set the UCS per the view as I have it on screen. So I can just freely orbit, click this button, it sets the UCS, come over to my GA grouping, I'll say 3D model view, and I'm not going to do it without labels. I just want some isometrics as well as elevations maybe. I can choose the default that's defined in the settings, or I could modify them at any time. I could give it a name if I want. I could say, hey, this is GA01. If I already had a GA drawing, I want to place this newly captured and created viewpoint, I can put that on an assigned existing drawing already. But I will go ahead and generate that. It generates any of these drawings, and these are just simple three-dimensional projections. They're not terribly complex like all the annotations and labels that we can create. But just let me create a couple of these. Let's look at it from this viewpoint. I'll create another, and there are other types, certainly.
You have such a, yes.
Yeah. Oh, I
You're
said it. Thank you, Brandon. See, he's going to teach the teacher. He didn't need me.
That's how I've done that. I've done it sometimes.
And it's the same thing with plate creation. We did so much plate work. Brandon probably has this ingrained in his process. You've got to set your UCS when you do a lot of these tools, as well as the drawings. All right, he saved me. All right, let me modify the settings. This time, I'm actually going to place it on an existing drawing, which from my list is GA01. I'll just go ahead and let it do that. We'll bring up the document manager again. When that's completed, and we'll expand it and take a look at our GA drawing 01. There's the preview. All right, it's very easily created. We could fully edit these. We can add dimensions and text. We can change the scale of these. You see that there's an open drawing button. It opens the AutoCAD drawing for us. We're looking at the 2D from paper space. And there's some uniqueness to how Advanced Steel functions. We have some viewports for details as well as the model view. I can drag these around as would be necessary. I can double click those to gain access to property information unique to the view, such as scale. If I wanted to change that scale to something larger than 3/8, maybe I wanted it to be 1 inch, whether that's going to fit or not, I can choose that. If I'm clipping the view in any way, I can alter those settings, symbols to use when I'm clipping, and so on. Just a lot of assistance in terms of how we generate drawings. We'll let this one process here and update the view, and I think you get a feel for what we might do. So very big drawing now. Let me point out one other one, that it is a parametric approach. And while we can do AutoCAD standard tools such as dimensions, we don't want to use that. We want to use parametric dimensions. And that way, if there is a cut drawing, we want to be sure to get the absolute size. So if I look at that, Brandon can tell us, yeah, indeed, that actual item is 8 feet in width. All right, it knows that whatever the scale may be, or if I have a cut section where I'm only looking at a shortened amount of the beam or column or plate layout, that I can get the true parametric dimension representation there. Okay, a few other items. Let me go back to the model view. Then we can actually get to some questions if anything has come in on the chat. I've not been watching that, but I'm sure Mary is. Let's see. Let's go over to our output tab. I mentioned the fabrication aspect. You'll see that we have the capability of NC and DXF output. You may note that we do have the ability to control settings of the numeric control, and often with many devices, whether they be water jets, plasma cutters, presses, we may need a certain file format. And going to the NC settings, often we see many devices want to see an NC1. So the files generated don't require anything more than just adding a 1 to that and saving that so that the NC that will be generated will actually do so. I'm going to pull down here, and actually let's do the NC first. Let me check one thing. I want to make sure I've actually numbered this one. I believe I have, but let's look in our model browser. That come up. Yep, I can see drawing numbers, part numbers are there. You could also have done so by opening the advanced properties of any object and looking at its naming. There is the single part mark, the prefix for the plate. When it's attached to an assembly, that's the assembly mark it's receiving with a capital P. Again, we can customize those settings to our shop's needs. So I have done so. Let me go back to that output tab, and we'll look at the NC generation. Data export on this. It's very quick. You didn't really get much option there. It's I'm going to sit for a minute because this one, as I said earlier, I think it has over 900 plates. That's just plates. We're not talking about the bolts and the beams and other items. I think that's generated by now. And also associated with that, the DXF files. That button is DXF for plates specifically. We have another DXF for other items or all items within the project. Sometimes we just want to get our plate stuff out there. Generally, with building vertical, we're talking about structures. Plate work is about the largest amount of tonnage we've got, and then we want to get that to the shop quickly once we've got that model aspect approved, and we can do so. Once we've done that, go back to our document manager. And when that comes up, we're going to expand another category. And we'll see that we have lists. I don't have any lists generated here yet, but we have the DSTV folders. Right? We have the list folders. We have the NC. There's any of the code information. You see each of that appended with that NC1 format. You could preview any of the code data if you need to. If we want to look at the DXFs, you can actually preview those in turn. And we actually see whether it has punch marks. We see the number. We see any scribe lines, anything else that would be necessary. And there's that long list of DXF files for all the plates that we had. I thought it would generate a lot more than that, but you got to remember that there may be 60 of P13. So all in all, here you can see those the marks for us in terms of that plate when we get out there for helping the assembly and erection in the field, lining those things up, the welders and erection team. Okay, so a lot of information that can come out of the tool. Hopefully you've seen how we might approach utilizing Advanced Steel. I think there was one other slide here. Now that we've seen inside a little bit of application, let me come back to my PowerPoint here. Go to my next slide. Well, I seem to be missing my slide. Well, there was one. I had a crash right before, so I may have missed my particular file. So, all right, it's not there. Let's just I'll kind of describe it to you as best I can. Once we are back in plant, and we need to think about one other thing. in that I mentioned that folder structure, and we do need to copy that over. If I can, let me bring up the Advanced Steel project. I mentioned that it is project-based as well. I'll slide my browser over here so you can look at my File Explorer. Inside of that feeder project, that first long conveyored model that Brandon gave us, you'll see that any bills of material that are generated, databases associated with this that are specific to this project, detailed drawings. There you see all of the assembly drawings, part drawings if they're in here as well. We need all of those items inside that plant project also. And that way the steel detailer, if it's applicable for the company itself, we work right from that project XML location for the plant project. So, all right. Well, that's about all I had. Brandon, before I kind of turn it over to Mary and maybe to follow up on any Q&A that we may have had come through, did you have anything else that you wanted to offer? You think would be valuable to anybody?
There is something else it does. It also produces your cut list. It produces your assembly list and all that stuff too. That in that list area, it's that I found that we needed for shops and stuff, and that's very handy, especially if you follow the rules and build your model right. It really does an incredible job of that. Yeah.
That's true. We certainly need to build the model correctly because we're talking about fabrication stuff here. We got to have these true size, and if we're sending this out to a table or a beam line, it needs to be correct. So obviously we validate. Like Navisworks, Advanced Steel has collision detection on board, and that helps us to see whether we may have something that hasn't had a cut or a coping applied to it.
Yeah.
Yeah, those lists that he's talking about are right here. Whether we have bolt lists, that's handy right there. Whether we look at bolts that are organized by assembly or all project together, we can get a total tonnage of that. There are other types of drawing lists itself, just in terms of the project. We can separate them by parts and assemblies. Anchor lists, stud lists, if we have, we have a project where we actually have studs to flange and the building deck. Parts lists, seeing a material list takeoff for everything within the entire project. Here you can see a sample. If I zoom in here a little bit, you can start to see imagery that can even be applied. Saw lists with pictures. This one is very handy. So when you have angles and you're out in the shop and you're looking for this information, going to the tabular form is very helpful for that particular part. We can see the size and confirm that there's that particular part name. So thank you, Brandon, for bringing that one up. Yeah, the lists and reports, just like in Plant 3D that we can create reports and parts lists and things, bills of material. That's why we work with these database project-driven applications. All the data we can get out of it. We really want the information. Okay, well, if that's good, I'd like to pass it back over to Mary. Mary, have you seen any Q&A come in or anything else we maybe need to pass on?
No, it's been pretty quiet, although there was one question about lists. Somebody was asking about bills of materials and the types of parts lists that are available, and you guys just must have seen that or just dreamt it, but you covered it very, very well. So other than that, there are no other questions.
Yeah, Brandon was being clairvoyant there, I think.
I would like to say it also, this program does a beautiful job of cross-referencing. If you open any of your single parts, it tells you where that assembly, which assembly that's in. And on those lists, it does the same thing. It really does a thorough cross-referencing job. I like that about it. Really, really good program.
One other thing I'll mention that Brandon has pointed out, if you're a Revit user, you know what it's like to work share. If you're a Plant 3D user, there's the ability of how we need multiple users generating all that plant data. Advanced Steel has a multi-user approach also. Yes. And he pointed out a couple of things to me. If you want, go ahead and add something on that, Brandon, if you like.
Well, just in the multi-user, I know that in some of the steel programs out there that when you produce your drawings, you can have like thousands and thousands of drawings in one file. And in this thing, you can actually pull those groups into a link into your main model with a multi-user deal. And actually just select a group or an area or an assembly, and you can pull that assembly into that multi-user file, and it has the other stuff in the background, but that is really all you're handling. So you're not handling this massive model. You're handling just what you're working on, and then you can actually number it there and do the drawings in that file so that you just have a small portion of drawings to look over and just, you know, check. And then when you check it back in, it actually takes those numbers back with it. And so it's intelligent, and you can't, the beauty of it is you can't override each other's work with this program. If you've got it checked out, your friend can't check that out, and he can't overwrite what you're doing. And when you check it back in, that main model is intelligent, and he can't overnumber your numbers with other. Once you've numbered it, if he has another piece checked out and he numbers it, it automatically knows, oh, these numbers have already been used, and it'll number it differently, so it doesn't have these overlapping numbers. And I think that's a powerful part of this program that we have just begun to mess with. And it comes in really handy on really big models, and lots of people working on big models. It really saves you, and it saves you a lot of time looking over. I've seen steel models with literally like 6,000, 7,000, 8,000 drawings. I mean, that's a lot of drawings to look through. But if you take those and break them down to bite-sized pieces, it's a lot easier to check those drawings, look at them, and just not just be overwhelmed with the amount of drawings you got to look through.
Yeah. As with anything 3D modeling based, view management and database management is really important. For any companies that utilize Autodesk Vault in conjunction with Plant 3D, it probably sounds a lot like Vault. You're kind of checking in and checking out items, checking things back into that database. That, in essence, is what it is doing.
Yeah, it works very much like that, yeah.
All right, is there anything else, Mary?
No, that's about it. And I want to thank you, Chris, and I really want to send a special thank you to Brandon. This is incredibly impressive. I've been in this industry for a long time and seen a lot of products and a lot of what people have done with it, but this is certainly very impressive, and I want to thank you. And I want to thank everybody that's joined us today. This has been recorded. We will be posting it as soon as it is available, and certainly be sharing that with anybody so you can share it with others that you think would benefit by seeing this this demonstration. And also there's 2 handouts available that you can download on the handout tab. One is more about CAD soft consulting, and the other one is kind of a quick start on how to get started with Advanced Steel that I think you would find very helpful. So with that, I am going to thank you all again, and thank you, Chris, thank you, Brandon, thank you, Autodesk, for inviting us to participate, and I wish you all a really good day, and we'll end our broadcast now. So thank you.
Okay.
Thank you, everybody. Have a good day.
You too.